Now we will discuss about electric flux. So this flux, it is a property of vector fields. You know what is meant by vector, and we discussed about field. So this is one of the property of vector field. So first of all, we will define or what is meant by electric flux. So the definition of electric flux is very simple. It is the measure of the total number of electric field lines passing through an area normal to that area. The number of field lines passing normally through an area is the measure of electric flux. Okay, so we'll see the definition. It is the electric flux through a given area held inside an electric field is the measure of the total number of electric field lines passing normally through that area. Because by the definition of electric field, already we discussed, electric field lines per unit area indicate the strength of the electric field. So to get the total number of electric field lines, we have to do what is, it will be indicated by the electric flux. Okay. Now we will see area vector. So now you may think that area is a scalar quantity, how it can become a vector. So here, to define electric flux, we are introducing a new concept of area vector. So this area vector is nothing but it is a vector whose magnitude is equal to the area and the direction is in the direction of the outward normal direction. And why we are specifying about area vector is that to define or to study more about electric flux, we need the concept of area vector. Okay, it is a vector whose magnitude is equal to the area of the surface and the direction is in the outward normal direction. For example, if the area is in the xy plane, the direction of area vector will be along plus k direction in the outward normal direction if it is a closed surface. Okay. Now we'll see the diagrams showing the direction of area vector and electric field and if they are making some angles. So first case, here you can see that these electric field lines are parallel and equidistant, which shows that it is a uniform electric field. And here you can see an area, and here the area vector is perpendicular to the area. Not only here, everywhere area vector is perpendicular to the area and the direction of electric field and area vector are same, or we can say that angle between electric field vector and area vector are same, or in other words we can say that this area is perpendicular to electric field or area vector is parallel to electric field. So in this case you can see that the field lines, all the field lines which are coming through the surface are passing through. So we can say that here the maximum number of field lines are passing. So this is another case. Here you can see that this electric field is making an angle theta with the area vector. So here all field lines will not pass through it. Only the cosine component of electric field lines will be passing through that area. Okay. So for the flux only E cos theta will be contributing. So we'll see first case when electric flux if area is normal to electric field. So this is the diagram just now we discussed. Uniform electric field, a planar area, A is the magnitude and direction is in the same direction as that of electric field. So flux can be written as E into A. Why it is E into A? Because electric field is the number of field lines per unit area. So here we have to find the flux. So flux is equal to total number of field lines, which is equal to E into A. This is the case when area is normal to electric field, or in other words we can say area vector is parallel to electric field. Now we are considering the second case if area vector makes some angle theta other than 0 degree. So here it is the diagram. You can see that here area vector is making an angle theta with the electric field. So in that case, flux is equal to EA cos phi. Why EA cos theta? Why it is EA cos theta? Because all components will not be contributing for the flux. Only those field lines which are passing perpendicular through that area will be contributing for the flux. So flux is equal to E into A into cos theta. Now we are considering a closed surface. So if the surface is closed one and if the electric field is not uniform, so at different positions the values of electric field is shown E1, E2, etc. So in that case what we have to do? So what we have to do is that we have to consider small areas delta A1, delta A2 like that up to delta AN shown in the figure, and let theta 1, theta 2, etc. be the angles made by the area vector with the electric field. So we can find flux through each small area and we can sum up to find the total flux. So flux is equal to E1 into delta A1 cos theta 1 plus E2 into delta A2 cos theta 2 plus etc. Or we can write summation sigma E delta A cos theta, or we can write it as sigma E perpendicular, only perpendicular components E cos theta will be contributing. So E cos theta into delta A. Okay. Or instead of summation, already you have studied last year in physics. Instead of summation, we can use integration. So here we are writing total flux as closed. Like you can see that one integral symbol with a circle which shows that the closed surface integral of electric field. Or we can write closed surface integral E dot dA, that is equal to flux. Is it clear? So flux is equal to total closed surface integral of electric field. So what we discussed, that we can conclude now. So what we discussed about electric flux, and if the area is parallel to the area is perpendicular to the direction of electric field or area vector is parallel to electric field, flux is given by E into A, and if it makes some angle theta, so in that case flux is equal to EA cos theta. So this is the general expression. You can get the first expression from this. When theta is equal to 0, you will get flux is equal to E into A. What is phi, E, A, theta, everything? Phi is the flux, electric flux. E is the electric field and A is the area, and theta is the angle between area vector and electric field. Okay. Is it clear? Now for a closed surface we can write flux is equal to surface integral E dot dA. Now can you tell me whether it is a scalar quantity or a vector quantity? Yes, it is a scalar quantity. Why? Even though electric field is vector, area is vector, E dot dA, it is the scalar product of electric field and area vector, and hence it is a scalar quantity. Now what's the unit of flux? So whenever we are defining a quantity, we will try to define the or write the unit of that quantity. So here can you tell what is a unit of flux? What's the unit of electric field? Unit of electric field is either we can write it as Newton per Coulomb or volt per meter, and unit of area is meter square, and cos theta has no unit because it is trigonometric ratio of similar quantity, so no unit. So flux we can write it as, the unit of flux we can write it as Newton meter square per Coulomb or volt per meter into meter square or voltmeter. So the unit of electric flux is either we can write it as Newton meter square per Coulomb or voltmeter. Okay. Now we'll discuss one or two problems related to electric flux. So first question we'll see. If the electric field is 8I plus 3J plus 2K Newton per Coulomb, Calculate the electric flux through a surface area of 10 meter square lying in the xy plane. Okay. So here electric field is given 8I plus 3J plus 2K. And area is given 10 meter square. We have to write the area vector. So it will be 10 meter square. But it will be k cap. Why? Because it is in the z direction. So we'll write the formula. Flux is equal to E dot A. Here E and A are written in bold letters to show that they are vectors. So we can write flux is equal to E dot A, and you can substitute the value of E and A. E is 8I plus 3J plus 2K dot 10K. So what you will get? You will get 8I. Here no I vector is there in the area. So it will get only 2 into 10. You will get it as 20. Because AI plus BJ plus CK dot DI plus EG. Like that if you do, what you will get? AX BX plus AY BY plus AZ BZ you will get. So only here only K components will be there. 2 into 10 you will get that as 20 Newton meter square per coulomb. Okay. So now we'll discuss another problem. The electric field is given by 2I plus 4J plus 2K Newton per coulomb. Calculate the flux through due to this field over an area of 3J minus K. Here already that area vector is given. So directly you can find how to do. You can substitute flux formula. You can write phi is equal to E dot A. Now you can substitute the value of E. What's the value of E? 2I plus 4J plus 2K dot 3J minus K. So if you find the scalar product, what you will get? 2 into 0, because here no I components are there, plus 4 into 3 minus 2 into 1. So you can write it as 0 plus 12 minus 2. 12 minus 2, what is answer? It is 10. So you'll get it as 10 Newton meter square per coulomb. Is it clear? So this is the total flux passing through that area of 3J minus K. Sometimes when you are solving problems, you will get the value of flux as negative. So what's the significance of that negative value? Negative value shows that the surface includes a negative charge. Okay. And if you are getting a positive value, that shows that the surface includes a positive charge. Net charge included by the surface is, if it is positive, you will get the flux as positive value. And if the net charge enclosed by the surface is negative, you will get the flux as negative value. And whenever you are solving problems, that formula you have to write, and unit, it is very much important. You have to do the calculation properly, then you have to write the unit. Okay, thank you.